In this lecture, I am going to discuss the Biot-Savart's law. What is Biot-Savart's law? It is applicable for line current, surface current, and volume current. Consider a wire filament carrying current I, carrying current I. This is the elemental length dl, and this is the point where electric field is to be calculated. It is denoted dh inward because cross line is there inward, and this is the direction of vector r, and this is angles r. So according to Biot-Savart's law, this dh, this magnetic field, must be proportional to current I, elemental length dl, and the angle between this vector to the this conductor, this filament, ideal sine alpha upon, and this is the r square, where r square is nothing but r is equal to modulus of r. This is r square. Biot-Savart's law is also known as Coulomb's law of magnetic field. If we want to write dh is in terms dh equal to, then we have to add k, and k is nothing but constant of proportionality the value of k is equal to 1 upon 4 pi, constant of proportionality, k into I dl sine alpha upon r. Now we can write dh vector is equal to I dl vector cross r k upon 4 pi r square. How to write this one? Here k is equal to 1 upon 4 pi, which is correct. So we know A cross B is equal to AB sine theta. Here theta is the angle between A and B. Here angle is alpha between this vector and this vector. So if one is ideal and second vector is AR cap, it must be equal to ideal AR cap. Angle between this is sin alpha. So it is equal to ideal sine alpha. That's why I have written ideal sine alpha is equal to ideal vector into AR cap cross AR cap. Further, we know AR cap is equal to R vector upon modulus of R. but r vector upon r. So we can write dh vector is equal to ideal cross r vector upon 4 pi r. Now for line current, it is very important. For line current, I am taking ideal line current. I am taking ideal. For surface current, I will take k vector ds, because ds is not the vector quantity. Unit normal unit vector, it is a different thing, but area is not a vector quantity. It must be equal to j into dv. Volume is also not a vector quantity. So here it is a line current, it is a surface current. Sorry, this I is a line current, k is the surface current, and j is the volume current. Volume. What is the unit of I? We know unit of I is ampere. What is the unit of k? And many students say unit of k is ampere per meter square, but unit of k will be ampere per meter. Why? Because I am taking the value. Okay. Similarly, volume current. So here unit will be ampere per meter square, because I am taking only phase, only any phase of the cube. We can see using the example in line current case. This is dl. This is the current I. We can say this is the I dl vector, and current is current, unit of current is ampere. In case of sheet, in case of sheet, k is the vector, so k will be like this. K will be like this, and if we take small sheet, so value will be k vector, because this is the k vector. K vector dot k vector into ds, and k vector is the directional, so it will be in the form of meter, not meter square. Okay, so unit of k will be ampere per meter, not meter square. Third case, volume. This is the small volume, okay, and this is the j. Similarly, we can see only one face. Okay, if this is a cube, it may have this face, it may have this face, it may have this face, any face among 6. So here we can we can see any face. So ampere, so unit of j will be ampere per meter square, because uh, I am taking any surface, and surface is nothing but the area, height into. That's why unit of j is ampere per meter square.